Okay, we've made it to skill number 7, the final important task that we have to do for this chapter, and that is the law of cosines. Now, the law of cosines is just a little bit more complicated than the law of sines, so we tend to use this as seldomly as possible. It applies to situations where we know all three sides and we need to work out the angle. If you think about it, if we tried to use the law of sines to do this, we always would be having two unknowns amongst our four pieces of information, and we could never work out one of the angles. And in this case also, you'll see if we have side angle side, we are unable to get the missing side and an angle involved, and so again we can't do it. But if we have side angle side, we can use the law of cosines as with side side side. So an example that I think is appropriate to start with is if we have a triangle that's like this, that's 4 and 5, and we'll say that's 8. Okay, so it's clearly an obtuse triangle. We need to work out these angles here. The best way to do it is to start with the smallest angle first. We'll call that theta, and that's always opposite the shortest side. The law of cosines says that if we're looking for either this missing angle or a side that is opposite the angle that I know, it's going to be always this side that's opposite the angle I'm trying to solve for, squared, is going to be equal to 5 squared, the adjacent side, and that added to the other side making the angle squared, and then minus 2 times 5 times 8, and then times the cosine of this angle theta. That's why it's called the law of cosines, because it uses the cosine. It's always going to be easier if we look for the smallest angle first. You will not get into calculator problems where you're taking the cosine of a number that is greater than 90. All right? So when we do this very carefully, we get 16 is equal to 25 plus 64 minus 2 times 5 is 10 times 8 is 80. And then the cosine of our mystery angle theta, which we're solving for. We are looking for this. So we're going to very carefully do our math here. 16 is equal to then 89, and then minus 80 times the cosine of theta. Now resist the temptation to write 9 times the cosine of theta. This is 89 minus this times this, and we do not know what this is, so we can't just break that off and subtract it. But I can write this. 16 is equal to, actually I'll take away 89 from both sides, that's what I'm going to do. And when I do that, I get a negative 73 is equal to then minus 80 cosine of theta. And now I can divide both sides by negative 80. And I just get a decimal there. And that decimal then is going to be put into my calculator for the inverse cosine. Cosine to the minus 1 of 73 over 80. I'll hit enter and I'll get theta, and that's going to be approximately 24 degrees. So you can check that out. But that gives me my first angle. So if I know this angle right here is 24 degrees, I can then now go to the law of sines, because I've got an opposite side, and then I can solve for this angle next. Let's call that alpha, and its opposite side. So then I will have the sine of alpha over its opposite side, 5, is equal to the sine of 24 degrees over its opposite side, which is 4. And I can put this into my calculator and work it out. And so the sine of alpha is going to be equal to the sine of 24, which is about 0.41. And then that's divided by 4, and then multiplied by 5. And when I do that, then I will then do the inverse sine of this number, which is going to be, I guess I need to crunch that. It's going to be 0.41 and then times 5. So it's 0.5125. If I do the inverse sine of that, I get 31 degrees. So angle alpha is going to be approximately 31 degrees. Well, now that I've got that and I've got 24, I can then just add those up and subtract from 180. 31 and 24 make 55, so that's going to be an angle of 180 and 25 degrees. Okay, this angle here will be 125. Okay, so I've now solved this triangle for all three missing angles. The first time I use law of cosines, the second angle I use law of sines, always starting with the smallest angle and the next smallest angle, and then finally the obtuse angle you find simply by subtracting from 180. Okay?